Calculus BC, we are picking back up with this last example, example 5. We're told that we have a continuous function. It says use the table below to estimate f of 3.2. And is this estimate an overestimate or an underestimate? Explain why. I'm going to give you a little bit of a hint. Use a tangent line to estimate. So we've talked about getting a tangent line before. You can see we're trying to estimate f of 3.2. I'll tell you what, so much of this table is actually superfluous. We're not going to use it. We're focused on x equals 3.2 to get the estimate, but that means that our tangent line would have to be somewhere close to that. We're going to have a tangent at x equals 3. Remember, that's what we were doing last chapter. We were getting a tangent line at a particular x value, then we'd slide over a little bit. We could actually get bigger or smaller and get an estimate for a function. Now, this right here, in this table, you can see that, we've got our x values up here. We're going to have the point 3, 0.141. That's what f of x is. And we know that f prime of 3 from this table is going to be negative 0.990. Guys, that's the slope of the tangent line right there. So remember, I'm going to move this back maybe right over here. Remember how we can proceed with a tangent line kind of a situation. We've got our x1, y1 right here, so I could say y minus 0.141. And my m is actually negative 0.990. And I'll have x minus, well, my x1 is going to be a 3. Okay, so here's my tangent line equation. But I'd like to estimate f of 3.2. That means x is equal to 3.2. So we're going to plug in that x value of 3.2, and then we're just going to do some simplifying. Obviously, 3.2 minus 3, well, we're going to get an answer real quickly of 0.2, right? And we can actually add that 0.141 over. So at this point, let's just get our calculator out and just let it do some number crunching here. So I'll get negative 0.990 times a 0.2 plus a 0.141. And you can see pretty quickly we'd get negative 0.057. Negative 0.057. So again, what have we just found? Or 0.0, sorry. Good thing I just double checked that. So, the calculator's telling us pretty nicely that what we now have is f of 3.2 is about this value. But that's not the only thing that they want us to have. You see, they want us to adjust and say, we just made an estimate. Is this an overestimate or an underestimate? Now, there's one piece of the puzzle here that we've yet to use, and that is f double prime of 3. F double prime of 3 is negative. Okay, so that means f is concave down. Concave down like a frown. So here's really what we can do. If you were to draw yourself a little picture, and of course a picture can really help you out. Draw a concave down curve, and what you'll see is if you were to draw a tangent line. By the way, you could also, let me draw another concave down curve just like over here, and let's just say that your tangent line was maybe over this way. I guess what I'm really trying to get you to see is simply this, that when your curve is concave down, let's just say that this was a 3 and here's a 3.2, your tangent line will lie above the curve. Likewise, if we were to draw this over here and say that this was 3 and over here's 3.2, well, that got a little sloppy. Like, let me maybe draw this off to the side, just so that perhaps it's looking more like this, and maybe here's a 3, and over here is 3.2. And if we drew a tangent line, see, it really doesn't matter where you're drawing it. The 3.2 would be over here. You can see that your tangent line is going to be above the actual curve. So we will have an overestimate. The y value on that red line will be higher than what's on the black curve. So we can say this is an overestimate. And the reason that we're going to have is to say because f double prime of 3 is negative. That's a good enough reason to have. Now, by way of comparison, I do want to quickly just talk about what would happen if you would have been concave up. If you have concave up, well, remember that means that your curve is like a cup. It would look something like so. And what would that really entail then? Well, if you had a tangent line, now any point on that tangent line away from the point of tangency would be below the curve. That would be an underestimate. So what we're seeing is when your second derivative is negative, you've got a concave down, your tangent lines will always lie above it. If you've got concave up, your tangent line is below it. So really that's all we've got going on here, but a classic type of a table problem. Hope that is making sense.